In this video, we're going to start talking about functions. So I'm on the second page of your notes, the second part where it says function. So you've already watched the video about a relation, so now we're going to get even more specific. So functions are a more specific example of a relation. And our definition is going to be, it is a relation. And this time, every input has exactly one output. So every input has exactly one output. If you remember, we've said this several times, your input is always your x values and your output is always your y values. So in order for a relation to be a function, every x has to have its own special y. Every x value can only have one y value. If it doesn't, then it's not a function. So on our notes, we have examples here, and then we have non-examples. So I'll show you what it looks like as ordered pairs, and then I'll show you what it would not look like. Okay, so we'll start with ordered pairs first. So list of ordered pairs: 3, 2, 5, 7, 9, 3, 3, 2. So you're looking at these ordered pairs. As you're looking at these ordered pairs, you're paying attention to the x values. So I have a 3, I have a 5, I have a 9, and I have a 3. If I don't have any repeating x values, then for all I know, it's a function. In this case, though, we have a 3 and a 3, so we have to double check the y's. Since this 3 has a y value of 2, and this 3 has a y value of 2, this is a function. We're good to go. Because remember, every x has to have its own individual y. Every time this x is a 3, I have to see a 2. X is a 3, I saw a 2, that's a function. So let me show you a non-example. Let's say I gave you 5, 6, 7, 8, 9, 10, and 5, 4. So again, we're going to do the same thing that we did before, and we're going to look at our x values. When we look at our x values, I have a 5, a 7, a 9, and a 5. This time we have one x value that repeats, and that's 5. Every time I see 5, I should see a 6 with the y. Every 5 in this function creates a 6, but in this case, this 5 created a 4. This is a no-go. This makes this not a function. So this is not an example of a function. Now, let's go back up to our examples and let's look at another one. Let's say I gave you 5, 3, negative 2, 1, and 7, 4. When you look at these, again, you're going to look at your x values. When I look at my x values, I have a 5, a negative 2, and a 7. In this example, I don't have any repeating x's. If your x's don't repeat, then all you can tell me is it's a function. Again, if none of your x values repeat, then it's automatically a function. And you might want to write that down. X values, if they don't repeat, it's automatically a function. Every single time, no matter what. If you don't have repeating x values, then it's a function. Remember, if you do have repeating x values, if your x's repeat, they have to have the same y. If they don't have the same y, then it's not going to be a function. Let's look at one more set of a non-example. So I'm going to give you 5, 2. I'm going to give you 7, 2. And I'm going to give you 5, 5. So when I look at this, if you notice the y values repeat, we don't care. Y values can repeat. But the reason why this is not a function is because I have a 5 and a 5, and it made a 2 and it made a 5. You can't have that. Every time I see this 5, I need a 2. Every time I see this 5, I need a 2, and that's not what happened down here, so it's not a function. Remember, y values don't matter. Every y value could be the same. We don't care. It's x's. X's need to have the same y every single time. Okay, we're going to move on to this middle section. In this middle section, we are going to do mappings. So if you remember when you make a mapping, which you should have practiced this by now, you got x's, you got y's. I'm going to put 1, 2, and 3 here. And then over here, I'm going to put 4, 5, and 6. When I create a mapping, the same thing is true. Each x value can only have one line that is leaving that number. So I'm going to have 1, 5, 2, 4, 3, 6. If you notice, every x only has one line that's leaving, no double lines. Now I'm going to go down to my non-example, and I'm going to go 1, 2, 3 again, 4, 5, 6. This time, I'm going to say 1, 5, 2, 4, 3, 6, and I'm going to get tricky here, and I am going to add 3, 5. At this point, red light should be flashing in your brain. The 3 has 2 lines leaving it. If you see a mapping and one of the x values, and again, we only care about x values, has a number where there are 2 lines leaving it, that makes it not a function. Because remember, if you listed it as an ordered pair, now you would have 2 values or 2 ordered pairs that have a 3, 3, 5, 3, 6, and they don't have the same y value. We don't care if the y's have 2 lines going to it. That doesn't matter. The last thing we're going to talk about with a function and being able to determine if something's a function or not is looking at a graph. So this is really important to determine if a graph is a function. You're going to do something called the vertical line test. So I'm going to plot some points on my graph, and you can do the same. They don't have to be exactly the same, but generally the same. Yeah, you probably should actually just plot the same points. So when I look at this graph and I start on the left and I move to the right, I'm going to draw vertical lines on this graph. So I'm going to draw a vertical line here, I'm going to draw a vertical line here, a vertical line, another vertical line. Each of these vertical lines where we had data points, if you notice, each time, each line only had one data point. So the line goes through only one point at a time. This is a pass. It can only cross one time. So you can draw vertical lines all the way across this graph, but every line you draw can only cross one time. It can only have one data point through it. So let me show you a non-example, because sometimes when you see the non-example, it makes more sense. This time, I'm going to put a dot here, I'm going to put a dot here, and this time I'm actually going to connect my dots, which we'll talk more about connecting dots in a minute. That wasn't very good. This is my graph. When I start drawing vertical lines, you'll notice this vertical line that I drew, there's a point here and a point here. I crossed 2 times. If you cross 2 times, that means you have failed the vertical line test and this is not a function. Again, if you go back to ordered pairs, if we wrote these 2 data points as ordered pairs, you would be at 0, -1, and you would be at 0, 2. So if you compared your x values, they're both zeros, but they have different y values. If I have a 0, I always need to see -1, and that's not the case. So this is how you can determine if a relation is a function. You can compare their ordered pairs, you can create a mapping and compare, or you can check using the vertical line test. From here, you should be going to Google Classroom to check to see what assignment you need to do next.